Hi, this is Real World Audio, and let's have another look at the electrical panel. I hope most of you have are reading the comments and have read John Sveda's comment about stacking your circuit breakers on the same leg. So this is a United States breaker. And it will apply to all of you who are in the US. In other countries, I am not sure how your breakers are, how they are wired, but let's look at the technical wiring data. How does it look like? Sorry, it's on the side. And this is how these are all the individual circuit breakers, individual fuses basically. And you see, so rotate that 90 degrees and you get them here. So they are stacked on one side and they are also stacked on the other side. So why they are put in these two columns? And that's because I have the electricity coming in from above. So it comes into this unit from descending from up there. And there are two big lines, and the potential difference between them is 240 volts. So yeah, for those of you who are in Europe and are looking at this, yes, I tell you that in the United States, we also have 240 volts coming into our houses, just as everyone has in Europe. However, what the difference is between us is that that 240 volts is center tapped. So here, that's the thumb. I'm giving the thumb. So the thumb is the center tap between the 240 volts, and each side carries a 120 leg and ground, and then this carries the other 120 leg here in the center and then ground. So when I install these breakers here, there's the connection underneath on the other side of the breaker that connects to the hot leg, the leg that was coming down here. And this end here, that's it's not connecting anywhere, it just goes out to your appliance. And the negative leg is, there's a big bar here underneath. One day I will open it up and show you, and the negative leg will go from that bar. And also the safety ground is also going from the exact same bar. So how are these guys wired inside? So these are not on one leg and that's on the other leg as one would think, but they are alternating. And here's this what the diagram tells us. So basically, as you go, the top one is connected to that leg and the one underneath is connected to the other leg. First leg, second leg, first leg, second leg. So basically, if you want to install your stereo gear on the same leg, then if you put them on top of each other, then they will be one leg, other leg, one leg, other leg. So you will be alternating them. And the reason they did this, because this way there's one leg, other leg, and look at that, AC, you can install a 240 volts device in the United States by putting in essentially a double breaker, which has one leg of the 220 or 240 and the other leg of the 240. And this is why, like for the AC, AC is running at 240 volts. Let's look at the dryer, also running at 240 volts, and the range is also running at 240 volts. And I have the water heater, it also, right here, water heater also runs at 240 volts. So that's how it is produced. So now let's see what I did to my stereo system. They are not stacked on top of each other, because then I would get, when I connect the devices into the outlets, for one device, when there is 120 volt peak up, and the second device would get that 120 volt peak in the opposite direction. So at every time between this breaker and that breaker, there is 240 volts difference between them. And if you look at these two breakers, then between this and this there's 0 volt difference. So how I put my stereo gear is that I put this is my number 3 dedicated outlet, and then I flipped it here. Next one is upstairs bedroom and number 2 outlet, and then I have projector there, number 4 outlet, something else, number 1. So I have 4 dedicated lines for my audio. 1, 4, 2, 3. These are the orders that they appear on my wall. And if it's not the same here, doesn't matter really, just as long as you know which is which. But the important bit is to leave out a space between your dedicated lines, and then you will have them at the same phase, at the same polarity. And I did an experiment, so just tag them together. So when you do that, then basically 2 of your connectors will be out of phase with each other, and in that case you will have hum in your system. So my turntable, from my turntable there was quite a bit of hum coming, and also the black levels when I listen to music, they became gray levels. So it's like there's a nervousness in the sound and the background is disappearing. So that's why it's important to install your breakers with one gap in between them when you are doing it for your stereo and you have multiple dedicated lines for your audio system. So thank you for tuning in. This was Real World Audio, and have your electrician check out your box. And also one more thing is that regularly have an electrician come out and retighten the connections, because the wires running into your breakers, because there's so much current going through them, they rattle, vibrate, and the connection loses. So they need to be periodically retightened, and that will make a noticeable difference in the sound when you get proper current delivery instead of intermittent current delivery. Because of the vibrations, there's not a permanent connection between the wire and the circuit breaker, so then it's just the current is going like ta 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 ta, and it rattles 50 or 60 times a second, as many as your line frequency is. So thank you for tuning in, and have a better system, and just get an electrician and do these things for you. Thank you. Bye bye.